Hi, my name is Annoesjka Cabo and I am a math teacher at TU Delft. For the exhibition at the Teaching Lab about the academic heritage of TU Delft, I was invited to pick an object connected to math education from the special museum collection of the TU Delft Library. This impressive collection is stored in a large depot underneath the library's reading room. In this depot, I was introduced to these beautiful models of hyperbolic paraboloids. I immediately knew this would be the object I would like to show, and I'll explain why. Among other things, I teach calculus. This is a basic mathematics course for first-year engineering students. In this course, almost all students are confronted with the notion of a function of two variables. And they have to understand the behavior of such functions in special points like extreme points and saddle points. These points are called critical points of the function. Since 2014, a growing team of math lecturers is innovating the first-year math courses. This involves recording short pre-lecture videos in which an introduction to a new mathematical concept is given. One of the videos I recorded for this project was about critical points. A problem with functions of two variables opposed to functions of only one variable is that it is really hard to draw nice graphs of these functions because they live in space. Here you see what this looks like. The surface of this example is called a hyperbolic paraboloid. Wouldn't it be nice, I thought, to show a 3D model of such a surface in my video? There must be models like that somewhere at our university. At the time, I did not know about the collection of the library and I started off on a quest for a suitable mathematical model that I could use to show a saddle point on a hyperbolic paraboloid. I didn't find it. I really tried hard at the Faculty of EMCS, at the Faculty of Civil Engineering, at the Faculty of Applied Earth Science. Such models were no longer in use. Okay, I thought, then let's try to print a 3D model. But no, that's too wild an idea. So I gave up and recorded the video without the 3D model. Now everybody understands my happiness when I discovered the models of hyperbolic paraboloids in the depot. Let's think about its use in the past. Students learning about functions of two variables could have a look at this model to understand its features. This is what a mathematical formula looked like. There was a whole catalogue of this kind of models. Here you see the entry corresponding to this model and its price, 5 mark 60. What are the possibilities in the present? Another great outcome of this exhibition is that a modern version of the model has been 3D printed at the Faculty of Architecture. Here it is. It's a shiny, beautiful, brand new and sustainable hyperbolic paraboloid that I can touch with my bare hands because it can be easily cleaned. Last but not least, modern technology can also be used to make virtual 3D representations of the mathematical formula. Computer graphics, for instance, was used to design this object that I can move freely in such a way that you can look at the surface from different viewpoints. Interested in the practical applications of saddle points and hyperbolic paraboloids? All right then, treat yourself to some of these famous potato crisps. How are they stacked in their tubular container without cracking? Because they are designed in the shape of hyperbolic paraboloids. And finally, next time you are in London, take a look at the roof of the Olympic Velodrome to enjoy the hyperbolic paraboloid as used in its saddle roof construction. It turns out that such a roof is easily built from straight beams. Ask your architecture and civil engineering colleagues how.